Welcome to another exciting educational video brought to you by Obvision Concepts Academy. So today we'll be looking at IGCSE Maths, and the topic for discussion today is polynomials, and basic operations, extended operations, basic operations. All right. So it promises to be an interesting topic for today. At the end of the lesson, we'll be able to understand what a polynomial is and recognize its degree, add, subtract, and multiply polynomials conveniently, divide polynomials by a binomial using long division or synthetic division, use the remainder theorem to check results, and simplify problems. Finally, handle polynomial expressions in IGCSE-style questions. So subscribe to our channel. Consider subscribing, please, if you have not done so. This video also promises to be interesting. Make comments on the comment section, engage us, and share the video, please. All right, we'll dive into what we have for today. What is the conceptual explanation? Conceptual explanation. Explanation. Okay, of polynomials. Okay, so a polynomial is an expression made up of terms of the form. You have coefficients. This is the form. Coefficient times variable raised to a power. All right. Okay, so coefficients, then the variable raised to a power. Example of a polynomial is 3x cubed minus 2x plus 7 is a polynomial. Okay, now first of all, this form I'm talking about is what I can see here. So I have a coefficient. Coefficient is the number before the variable. Okay, this is coefficient. I call this one coefficient. Number before the variable. X is the variable, and the variable has a power or an exponent. All right. Okay, so you know, there are other forms. You have something like this. This is quadratic. Why? Because the highest power of the variable is 2. For polynomial, the highest power of the variable is more than 2. So I have 3. Example. But what makes something not a polynomial is negative power. So if I have negative power, these are the things that make not a polynomial. Negative power or negative exponents, This, secondly, if I have fractional powers or fractional exponents, and if I have variable in the denominator, all these conditions will not make an expression a polynomial. So the degree of the highest power of x the degree is the highest power of x. I beg your pardon. The degree is the highest power of x. So this exponent now, the degree is 3. So if I have 5x raised to the power 4 plus 3x raised to the power 2 plus 1, the highest power of x here is 4. So that has degree of 4. This polynomial has degree of 4. So, in a nutshell, a polynomial is the form, the expression that have this form. Generally, that's the definition. Coefficient times variable raised to a power or an exponent. Okay. So again, think of polynomial as a set of building blocks. Okay, higher powers are taller blocks. Okay, so let me just put these thoughts on the board. So I say think of a polynomial as a building block. So if I have x to the power 0, this one is a small block. Next one is x to the power 1, it's a medium. X to the power 2 is taller, and x to the power 3 very tall, and so on. So the degree, again, the degree is what? Degree is this exponent. Shows us the taller blocks. So operations simply rearrange or combine these blocks. Operations simply arrange or combines these blocks. So what are operations? Operations, addition, subtraction, division, multiplication. These are the basic operations. Okay, so if I want to do step-by-step working of what I have just said now, the first thing I have to do is to show us addition and subtraction of polynomial. Addition and subtraction of polynomial. Okay, so you can only combine like terms. So there's a concept known as like terms. If, for instance, I'm asked to add two polynomials. First one is 3x squared plus 5x minus 2 plus x squared minus 3x plus 7. If I'm to add this, first of all, I will combine x terms. I will combine the x, combine the x squared terms. So anything that has to do with x squared, I'll combine them, right? Okay, so I'll walk through this. I will say 3x squared plus x squared, right? Then I will combine the x only terms plus 5x minus 3x. Then I'll combine the constant terms, minus 2 plus 7. See, as I'm combining them, I'm taking the operations along with them. So this is 3x squared, 3x squared. When I want to take x squared, I will take the operation before it. Mind you, this plus it's not affecting what's inside here because it's plus. If, for instance, the operation here is minus, when this bracket sign is opened, every operation inside here, inverts. So if there was a minus here, this will become plus, and this will become minus. But because we have plus, everything is just normal. Okay, so I'm combining all the x squared terms, that's collecting like terms. I'll combine all the x terms, you understand, with the operations. So the operation before it will also join the numbers or the terms and combine. And also I have the constant term, the minus sign in front of 2 and the plus sign in front of 7. So at this point, I will just combine these two. These two will give me 4x squared, and this one will give me 2x, and this one will give me plus 5. So this is the final answer for this addition. 4x squared plus 2x plus 5. Okay, so let me do a subtraction example. So a subtraction example, say subtract two polynomials. If I have this polynomial here, 4x cubed minus x plus 6, then minus x cubed plus 2x minus 4. So these are two polynomials I'm going to subtract. This is the operation I'm working on. So again, for this sign minus, before I open this bracket, I need to change all the signs inside of it. So let me go. 4x cubed minus x plus 6, then this is minus x squared, x cubed again, then minus plus is minus 2x, minus minus is plus 4. Okay, so at this point, I'll combine all the like terms. So this and this together, collect like terms, 4x cubed minus x cubed, then the x component minus x minus 2x, and the constant term plus 6 plus 4. So this and this, 4 minus 1 is 3x cubed, then minus x minus 2x is minus 3x, and 6 plus 4 will give me plus 10. So this is the final answer. What I have here is 3x cubed minus 3x plus 10. That will give me the final answer. Okay. So move on to multiplying polynomials. So if I have this example, 2x minus 3 and x plus 5. That's to multiply them. So we're going to multiply them term by term. Okay, so I'll just do a directional sign for us to follow in the multiplication process. The first thing you do, multiply this first term by the first term here. First term in this bracket by the first term in this bracket. So 2x times x is 2x squared, right? Then this same first term in this first bracket, I multiply it by the last term of the second bracket. So 2x times 5 is plus 10x. Then I have this minus 3. Minus 3 multiplied by x is minus 3x. The minus 3 multiplied by plus 5 will give me minus 15. Okay, so I will now work on the like terms. So I have 2x squared, then plus 10x minus 3x will give me 7x, plus 7x, and minus 15. So this is the multiplication of that polynomial. Okay. Okay, so this on the board is a multiplication that we need to do. This one is 3 terms and this one is just 2 terms. There's nothing to worry about this. Just take this one, multiply by each of the term respectively, and write down the answers. So for the first one, x times x squared is x cubed. Then x times 2x is 2x. Then x times 3 is 3x, right? Then for this one, minus 1 times x squared is minus x squared. Minus 1 times 2x is minus 2x. And minus 1 times 3 is minus 3. Okay, so you now collect like terms. So this is the only one that has a term that is positive. That's 3 raised to the power 3. So I have x cubed plus, okay, the s squares. How many s squared do I have? So I have this only one s square I have. This is supposed to be an s square. Yes, because this time this is s. Okay, so this 2x squared minus s squared is just x squared. And this and this are like terms. That's 3x and minus 2x. So this and this will give me x plus x plus x. And finally, I have minus 3 standing on its own. So this is the product of these two factors. Okay, so we have a polynomial that we need to do division. So for the division that you do for polynomial, this is the divisor. So you say x plus 2. So we're going to be using the long division method, and we're having this other term here, 2x cubed plus 3x squared minus x plus 5. Now, you are going to be working with the term that has the highest power, and you go down. So I'm going to be dividing this 2x cubed, because it's the one that has the highest term. That's the highest power. 2x cubed divided by 2x. So if I say 2x cubed over x, not 2x, 2x cubed over x. So you are dividing this by this by this, sorry. So this is x cancels here, and this is 2. So what I have here is 2x squared. So if 2x cubed divide 2x, I have 2x squared. So we are working with this term and this term and the following term, this term and this term only. But when you have divided this by this, you now multiply this by the two terms here to get something under here. So I've done this first one. 2x cubed divided by x will give me 2x squared. Then 2x squared times x will give me 2x cubed again. Then 2x squared times 2 will give me plus 4x squared. So I rule my line and apply my minus operation. So 2x cubed minus 2x cubed will give me 0. Then 3x squared minus 4x squared will give me minus x squared. After I've gotten this one, I'll now drop down this other two. That's x and 5. Okay, so I'll do the same thing here. So it is now x squared divided by x. That is minus x squared over x, right? So this will cancel this, so we'll have minus x. So this divided by this will give me minus x up here. So minus x times x will give me minus x squared. Minus x times plus 2 will give me minus 2x, right? Then I rule my line and put my minus sign here. So minus x squared minus minus x will give me 0, because minus will give me plus. And minus x plus x squared minus x squared plus x squared will give me 0 here. And minus x minus minus 2x is minus x plus 2x. Minus x plus 2x will give me x plus 5. This 5 I drop it down. So this is what I have left. So this x divided by x is 1. 1 times x is x. 1 times 2 is 2. So by the time I do the math here, I have 3. So this is the remainder. So the division, this divided by this will give me 2x squared minus x plus 1, remainder 3. Or I can do it like this. 2x squared minus x plus 1. Then I will now say plus 3 over x plus 2. Either way is the answer. I'm not teaching you.
How can minus and plus put together in this one? They said 2 and negative something equals positive. That is
Yes, minus minus is plus.
So minus x squared minus x plus 5 plus minus and plus.
It's plus.
Which one are you going with, minus or plus?
This minus will override anything that is here. Not yet, not yet. Polynomial f of x is equal to divided by. Okay, so we have the remainder theorem. So for a polynomial f of x dividing by x minus a gives a remainder. If we divide this by this and it gives a remainder f of a, that is f of a, this particular constant here, f of a. So if, for example, they say find the remainder when f of x, okay, which I can define as maybe 3x cubed minus 2x plus 1. Let me use this one for example. Is divided by okay, so my f of a, let me say by x minus 2. So in this kind of situation, f of a is f of 2. Because from here, remember that theory, x minus a is equal to f of a, right? So I can now say, therefore, f of 2 will now be, anywhere I see x, I put 2. So it's 3, instead of having s cubed, I have 2, then cube minus 2 into 2 plus 1, right? So this is 2 times 2 times 2. That is 2 to the power 3 is 8 times 3 minus 2 times 2 is 4 plus 1. So 3 times 8 is 24. Then minus 4 plus 1. This is 20 minus 20 plus 1, which is 21. So therefore, the remainder is 21. Remainder. The remainder is 21. From this, just simply take the remainder expression, the constant term there, let it be the what you use to substitute for x in the main expression. Okay, so we've come to the end of today's class, today's video. You were able to learn about polynomials, operations, addition, subtractions, division, and the remainder theorem. I hope this video has been informative for you. I'd like to thank you for viewing.